case. Now essentially what the case does is it holds in all the components, and it typically comes in four sizes: ATX full tower, ATX mid tower, micro ATX tower, and mini ITX tower. Now each of these cases has its own merits and functions. Now the ATX full tower is best for cooling and having multiple GPUs or hard drives, while the ATX mid tower is like the full tower except smaller in size and more convenient to fit on a desk. Now the micro ATX tower is significantly smaller, and once you have a smaller case, you also get more problems with managing your room and room within the case, and also keeping it all neat and organized. Now the mini ITX tower is kind of very special. It's a special purpose box. Usually it's for like a home server or something, or a very small computer that you want to take with you somewhere. Now the factors in deciding what computer case you want is usually size, cooling ability, and cosmetics. Now along with size comes with like how many hard drive bays it has. So basically how much storage you can have, how many bays you have in the front of the case where you can put stuff like an optical drive or something that can read a photo thing. Next, we're going to move on to the CPU. The CPU is the brain of the computer, and its speed is measured in gigahertz, and that's GHz. Now, basically, there's a debate that goes on whether you want more cores or you want a higher clock speed. Now, generally, the thing is you'd rather have more cores. Like instead of getting 2 cores and getting like 3.5 gigahertz and getting 4 cores at 2.5 gigahertz, it's better to get the 4 cores. And this is essentially because having more cores allows for the workload to be distributed evenly more, and this essentially allows for the CPU not to heat up as much and allows it to take the workload better. Now on top of your CPU you typically have a fan. You can also do water cooling like I did on my PC, and basically that just keeps the CPU cool and running well. Now there's two different architectures, 64-bit and 32-bit CPUs. Typically you'll get a 64-bit. Now the CPU fits into a socket, and the socket is just on the motherboard, so you need to make sure that your motherboard and your CPU use the same socket. Now there's this thing you can do called overclocking. And when you overclock your CPU, essentially you make it run faster than the factory settings. And this has its merits and its cons. One of the cons is it causes the CPU to overheat. So you need to make sure you have really good cooling. And water cooling would be suggested if you're going to do some extreme overclocking. Now one topic I'm going to dive into really quickly is bottlenecking. Bottlenecking is essentially where you have one part, like for example an Intel Core i7, which is a really good CPU, but then you get like a 430 graphics card, NVIDIA 430 graphics card. And essentially what you're doing is you have one part that's really good and one part that's not very good. And then that not very good part is going to hold back the performance of the really good CPU, for example. So you really don't want to do this. You want to make sure all your parts are basically equal. Next, we're going to move on to the motherboard. Now, the motherboard essentially acts as a hub. As you can see in the photo, it shows basically all the stuff that's on the motherboard. Now, the motherboard connects the RAM, CPU, and expansion cards together, and it supports one single type of CPU socket. So again, you need to make sure that your CPU will fit into your motherboard. And the motherboard again comes in different form factors. Essentially, you would get basically the size of your case determines what motherboard you will get. Now basically you'll hear this terminology bus, and that's essentially a circuit that joins one motherboard to another part of it. So the higher quality the bus is, that just basically means the faster the connection will happen, and that's measured in megahertz. There's some factors like how you would choose your motherboard would be RAM slots, expansion slots, its size, and cosmetics. So RAM slots is basically how much RAM can the motherboard support. So typically you can get like 64 gigabytes, I believe, is like standard. That's the max amount you can get. Expansion slots, this is basically PCI 3.0 slots. So this is where you connect your graphics card. If you want, you got to think about this if you're gonna do like SLI, which is running multiple graphics cards. So you got to make sure you have enough spots. Other stuff you clip into here would be like a specific audio device, or a Wi-Fi network card. Now cosmetics, if you want to do like a theme, for example, like I have a red and black theme in my computer, and then size is basically, will it fit into your computer case? Next, we're going to move on to RAM, which is random access memory. Now, this is short-term volatile memory, which means once the power is gone, all the RAM is cleared. Now, most of your RAM is probably going to be DRAM, which is dynamic random access memory, and that just uses capacitors and transistors. Now, RAM speed is measured in megahertz, and essentially what that means is the RAM speed doesn't really matter as much. You should probably just get whatever standard. The only time RAM speed matters is when you're running something like a virtual machine or simulators. And typically you won't need any more than 16 gigabytes of RAM. Now something else that comes with RAM is latency. Now typically you want the shortest latency you can get, because latency is essentially the amount of delay that it takes to receive information. So getting the lower latency is better. Now we're going to move on to graphics cards. Graphics cards essentially control and enhance the graphics on your monitor. They're very specialized, so they kind of take away the load from the CPU of having to process those graphics and puts it on itself. And because of this, it has its own dedicated memory. Most of them come with built-in fans, and I think this is only for NVIDIA, but the more CUDA cores you have, the better performance. And having more fans does not mean the graphics card is better. It can actually mean it performs worse in terms of heat distribution. Now, it also has a clock speed once again, and that's measured in megahertz. So the higher that is, the better it is. Now, some factors when you're deciding whether you want to get a graphics card is how well does it cool, because heat is an issue. If it gets too high, it'll just shut down. Speed, how fast it is, what type of games are running on it, or virtual programs. The amount of cores it has, the more cores it has, the better it can handle. Memory, and this is again for more intensive programs. You don't want your memory to run out. And then there's also bits, so the higher bit amount is better. Next, we're going to move on to the power supply. The power supply powers all your computer's components, modular versus non-modular. So there's two types of power supplies. There's modular and non-modular. Modular power supplies essentially have no cords plugged into them, while non-modular power supplies have all the cords plugged into them. And I would recommend getting a modular power supply because they'll just make your computer a lot neater, because you don't have all these extra cords hanging out. And efficiency rating. So power supplies have basically an efficiency rating. I would suggest getting the best one, which is platinum, which is what I have. And that just shows how much heat it'll give off, how much electricity it'll lose in the process of sending it through the power supply. And one general trick you should know is the heavier the power supply is, the higher quality it is. And one thing I would always recommend is getting surge protection, and that would prevent any of your parts from being shorted out. Now, when deciding how much wattage you want, because the more watts you have in your power supply, the more expensive it's going to be. So you should only really get how much watts you need. So most things like graphics cards will tell you exactly exactly how many watts you need. So I would recommend generally you don't need more than 1,000, but generally like 850 would be good. And trying to get a platinum rating, I would recommend Corsair. It's a great brand for that. Now we're going to move on to storage. There's two main storage devices, and this is long-term storage rather than RAM. So there's a hard drive and there's a solid-state drives. So each has its pros and its cons. SSDs are faster, they're smaller, they generate less heat. However, they are more expensive. SSDs have no moving parts and they're quite durable and make no noise. So overall, they're recommended. But typically what you do is you'd get one SSD that has, let's say, 500 gigabytes, and you'd put like your operating software on it, so like Windows on it. So Windows boots up fast, and you can control panel really fast. You can do all that fast. And then you put all these like your documents and stuff like that on a hard drive. So you'd buy like a 2 terabyte hard drive. Because hard drives are a lot less expensive and they have a larger storage capacity than SSDs. So hard drives have moving parts on it, and they're more prone to breaking. One thing that can also happen in hard drives is fragmentation. So fragmentation is essentially where um, the way that things are stored on the hard drive, it's like writing it down on a big piece of paper. But um, sometimes your application gets broken up into two different chunks in that piece of a paper, and there's something in the middle of that, and that's basically fragmentation. So if that happens, you want to defrag your drive, which is this process in which you just make sure that all the applications are grouped together in their whole self, so it helps make